Okay, as promised, here is your video showing how to find the points of concurrency of a triangle. I will not show the in-center because I can't really do a construction on an iPad. Alright, so we're going to start with the circumcenter. Remember, the circumcenter is the intersection of the perpendicular bisectors. We'll start by drawing our triangle. X is at -2, -2. Y is at 10, 4. And Z is at 16, -4. I'll do my best to draw straight lines here, but it's a little hard. Oh, that one's pretty ugly. Not much better. Okay. All right. So again, the perpendicular bisector is perpendicular to the segment that it's drawn to at its midpoint. So the first thing we want to do is find the midpoints of each of these three segments. Okay, the midpoint of XZ is going to be the average of the x coordinates. So the average of -2 and 16 is 7. And the average of those y coordinates are -2. I just realized I wrote -4 over here when I meant -2. Sorry. Okay. And perpendicular, in this case, is just going to be a vertical line, okay, because we're perpendicular to a horizontal line. Okay, the equation of that vertical line is x equals 7. Okay, if we write the equation of the perpendicular bisector to YZ, we first need to find the midpoint. Okay, so the average of 10 and 16 is 13. The average of 4 and -2 is 1. So our midpoint is right here at 13, 1. And if we're going to be perpendicular to YZ, we first need to know the slope of YZ. Well, the slope of YZ looks like it goes down 3 over 3 or down 6 over 6, either way. That slope is -1. So the perpendicular slope will be +1. And the equation for that is a slope of +1. And we'll use the midpoint in our equation because that's the only point we know for sure is on that line. And we could already kind of see that these perpendicular bisectors are intersecting over here. We're going to draw the third one in just for fun, or to be sure. Guys, and for practice. So the perpendicular bisector of XY is going to be perpendicular to XY at the midpoint. So the midpoint of XY is the average of -2 and 10, which is 4, and the average of 4 and -2, which is 1. So 4, 1. And the slope of XY looks like it goes up 3 over 6. Okay, so the slope is 1/2. You can see that here, +1/2, up 1 over 2, up 1 over 2. So the perpendicular slope will be -2. So if we go down 2 over 1, down 2 over 1. And we do indeed see that our circumcenter is right here. And we'll label that M. Okay, the equation of that last perpendicular bisector, y equals slope of -2, and again use the midpoint, because it's the only point we know for sure is on the line. Okay, so we can pretty clearly see the circumcenter is the point 7, -5. Okay, but just to algebraically verify that, okay, we already see that x equals 7, so we could take that x equals 7 and substitute it into either one of our y equals equations to find out the y value. So y equals 1 times 7 minus 13 plus 1. That is -6 plus 1, which is indeed -5. So our circumcenter is 7, -5. On to the centroid. Okay, now remember we do have a shortcut for the centroid. Okay, but I am just going to draw the medians just so that we can, show for sure that the centroid shortcut works. So recall that the centroid is the intersection of the three medians of a triangle. Okay, and because I didn't actually ask you to write the equations for the medians here, there's no need to write the equations. If I do ask you to write the equations, then I want to see the equations. Okay, but we have those same midpoints from before. 13,1 and 4,1. Okay, and the median goes from the vertex to the midpoint of the opposite side. We'll do that with all three of them. Okay, and we can see that they're intersecting right here. It looks like it's around 8,0, or somewhere between 8 and 9,0. So we're going to verify using, remember, the centroid shortcut. Okay, so we can find the centroid by finding the average x values and the average y values. Okay, so -2 plus 10 plus 16 divided by 3 will give us the average x value. Okay, that's 24 divided by 3, which is 8. And the average y value is -2 plus 4 minus 2 divided by 3. And that equals 0. So your centroid is at 8, 0. And we will label that C. Okay. Finally, for the orthocenter, I'm going to redraw that triangle. X, Y, Z, and again we have to remember that the orthocenter is the intersection of the altitudes. Okay, and the altitude of a triangle is the perpendicular line that goes from a vertex, from the vertex to the opposite side. So it's going to be perpendicular to the opposite side. Okay, so it goes from the vertex and it's perpendicular to the opposite side, vertex, perpendicular to the opposite side. Okay, and it's possible for an altitude to be outside of the triangle, and we're going to see at least one of those, maybe two of those in this triangle. Okay, so we'll start with the easy one. The easy altitude to draw is from y to xz, because something perpendicular to xz is just a vertical line. Okay, so that altitude is given by the equation x equals 10. Okay, so the altitude from z to xy is going to be perpendicular to xy. And if we remember from before, the slope of xy is positive 1/2. So the altitude from z is going to have a slope of -2. So we start at z, and then we count a slope of -2. So that's up 2 to the left 1, up 2 to the left 1, and we keep going like that, up 2 to the left 1, up 2 to the left 1, up 2 left 1. Okay, and that's, okay, it seems weird, but this is the altitude here. Here's your height, right? There's your right angle here. So we kind of have to extend this xy to see the altitude to xy. And we're going to have to do something similar with the altitude from x to yz. And we're going to want to extend yz out so we can see where the altitude hits. And again, from before, the slope of yz was -1. So the slope of something perpendicular to yz is going to be +1. So we're going to go from x with a slope of +1. I'm going to just follow that right on up. Okay, again, here's your altitude here. Okay, but the point that we want to look at, that point of concurrency, is right up here. Okay, this orthocenter right here, we'll call it O. It looks like it's at the point 10, 10. Okay, but we want to verify that. Oh, we forgot to write the equations for the other altitudes. So the altitude from z to xy is the equation y equals -2, and we're going to use point z because, again, that's the only one we know for sure is on there, although it looks like 10, 10 is on there. But we'll use point z in our altitude equation because it's going from point z. So x minus 16 minus 2. And then the equation of the altitude from x to yz is y equals 1 times x plus 2 minus 2, using the point x. Okay, so algebraically, to verify the orthocenter, we already know that x equals 10 because we're given it in an equation. We could substitute that into either of our other equations. -2 times 10 minus 16 minus 2. So y equals -2 times -6 minus 2. That's 12 minus 2, which is 10. Okay, so we verified the coordinates of our orthocenter as 10, 10. And that is it. Those are the 3 of the 4 centers of a triangle. Again, the in-center is only, we can only do that by construction of the angle bisectors.